Welcome to my YouTube channel. So today in this video lecture, we are going to learn one of the very important experiment in communication engineering. This particular experiment is basically used in either it is in the analog communication or and also it is can also be used in digital communication. So this experiment name is either you can call it as pulse amplitude modulation, okay, or we can also call it as unipolar sampling. So basically, this experiment is extensively used, okay, even in the case of digital modulation, in which while realizing the pulse code modulation, we need this basic circuit for realizing the unipolar sampling, or the same circuit can also be act as a pulse amplitude modulator. So let's see this circuit. Okay, so I have already made this circuit. Okay, and then we have to see how it functions, how this particular circuit will be able to give you output that will be your pulse amplitude modulated signal, or it is giving output as a unipolar sampling. Okay, so whatever the input data that we are going to give to this particular circuit, it will be giving you the output as a unipolar sampled values. Fine. So now you can see in this circuit, we are having, we are using one transistor whose model number is BC548BP. And this transistor is connected in this particular configuration you can see, in which this terminal is directly connected to the power supply, and the power supply that we are giving is 6 volt. And here one resistor we have connected of 1 kilo ohm, and then we are taking the output from this particular terminal. Okay, so this output will be our either pulse amplitude modulated output, or it will be a unipolar sampled output. So for performing this sampling, what we are doing here is we are taking this to circuit configuration. You can see here we are having one resistor over here, another resistor is of 10 kilo ohm is connected in this way. Okay, and from one of the node I have connected over here one uh, square wave. Okay, so here you can see that I have connected through a function generator, I have connected one square wave, okay, whose sampling frequency I have taken equals to 10 kilohertz. So this sampling frequency you can choose as per your requirement. Fine. And here I have chosen the duty cycle equals to 50%. You can also vary this duty cycle as per your requirement. If you want to make it 20% or 30%, whatever, you can adjust it. Now, the important thing that we have to keep in mind over here is in this circuit, I have taken the V maximum value of this square wave is equals to 2.5. So its peak to peak value will be equals to 5 volt. Okay. Now I have added one DC value. Okay. Negative DC value I have added, which is equals to minus 2.5. Okay. So that the range of this particular square wave amplitude range, that will be varying from 0 to minus 5 volt. Okay, that you remember. Okay, so this value will be varying from 0 to minus 5 volt, so it will not be taking any positive value. Okay, and accordingly, while analyzing the circuit, if you want to analyze, then accordingly you have to put the values, because this square wave will be taking sometimes zero value, and some other time it will be taking minus 5 volt, because it is a square wave, it will be having two stable states. Okay, 0 volt and minus 5 volt, and that values accordingly you have to take while if you want to analyze the circuit. Okay, so first of all, here I have connected the square wave for sampling. Okay, and the input message signal should be connected from this node. Okay, I will remove this DC voltage. Okay, while connecting the our message signal over here. Okay, any message signal. So here I can connect the particular sine wave we can connect, okay, of particular amplitude, okay, and particular frequency, okay, so that we can connect at this point, and then we can sample this input signal, and we can obtain the sample output from this particular terminal. In the oscilloscope we can observe the output waveform. Now, how to start this experiment? Okay, because in starting this particular experiment, we have to First, we don't have to connect the message signal. Okay, I'm not connecting any message signal over here, but rather we are connecting one of the DC signal. Okay, first we have to connect a DC signal because we have to first establish a particular relation. Okay, in what particular value of input signals, what should be the minimum value, what should be the maximum value of the input signal, its amplitude range, what should be its amplitude range, that we have to decide. Okay, and then only we can connect the our message signal of particular amplitude variation, minimum amplitude and maximum amplitude, and then only we can get the sample output. So you will understand once you will perform this experiment. Okay, so you have to make this kind of table. Okay, this type of observation table you have to make, in which we have to take the input DC voltage, and then we have to uh, take these values. Okay, we have to make it 0 volt, 1 volt, 1.1 volt, 1.2, 1.3 volt, 5, 6, 6.1, 6.2, and 7 volt. Okay, and then we have to measure the output pulse amplitude. Okay, we have to measure the output pulse amplitude, first maximum value, and then next one is the minimum value. Okay, that we have to observe from the oscilloscope. Okay, then you will be able to understand in what range we have to give the input message signal so that it will be properly sampled. Okay, otherwise it will not be sampled. That you have to take care. Okay, in this unipolar sampling case, experiment or pulse amplitude modulation case. Okay, so let's see this one. First we have to make it 0 volt. Fine. So once you will make it 0 volt. Okay, once you will make it 0 volt, fine. Here you just come. So once you will make it 0 volt, then if you execute this one, okay, then here you can see there is no pulse which is coming in the output. Okay, so you just avoid, just ignore this spikes. Okay, these spikes you have to ignore because there is no pulse output. Once I will change this DC voltage, you will be able to see the pulses. Okay, it will appear as soon as I will change this DC voltage. Okay, so first of all, at 0 volt, I'm not getting any output voltage over here. Okay, so I have just written it as 0 volt and 0 volt. Okay, once I will make it 1 volt. Okay, just go back, you just make it 1 volt. So once you will make it 1 volt, then again a very small amplitude is there, but you are not able to see it. Okay, very small voltage is there, but you are not able to see it. Okay, so again I will be just making it 0. Okay, so I have just noted down this value that this output pulse amplitude is 0, maximum value is 0, and minimum value is also 0. Now once I will make it 1.1 volt. Okay, I make it 1.1 volt, just stop it. Once I will make it 1.1 volt. Okay, then hopefully you are going to see a certain, yes, so now it is appearing here. Okay, so here you can see that this output pulse is visible now. Okay, so now we can measure this amplitude. Okay, we can measure the amplitude of the pulse. Okay, so just stop here and then you can see what is the amplitude. Okay, so this is our measuring pointer number 2. Here you can see on the channel 1, pointer number 2, it is showing this value equals to 17.461 millivolt. Okay, so this value we have to note down. Okay, 17.461 millivolt. So here I have written it as 0.01746 volt. Okay, that value was in the millivolt. Fine, and then the minimum value is equals to 0. Okay, so this is the maximum pulse amplitude, and here it is the minimum pulse amplitude. So go back to here, and again you can see this is the maximum pulse amplitude and this is our minimum pulse amplitude. Okay, here it is 0 value. Okay, almost, it is almost 0 volt. Fine, so here it is coming as minus 4.587 microvolt, so you can just keep it as 0 volt. Okay, so this is minimum value and this is your maximum value. Fine, so that we have to note down in the actual sheet. So I have noted down these values. Now I have to further change this value. I can make it 1.2 volt. So you just make it 1.2 volt. Fine. So one thing that you can see that once the DC value here is equals to 1.1 volt, then this pulse is actually starts appearing in the output. Okay, that you remember, when this voltage is 1.1 volt. So then pulse will starts appearing, and up to 1 volt that pulse was not appearing at all. Okay, you can analyze the circuit. That will give you an idea that this transistor was not turned on. Okay, it was off, it was in the off condition, and because of the off condition, there were no current in the circuit, and therefore you were getting the output equals to 0. Fine. But once this input voltage becomes 1.1 volt, then a small pulse is appearing in the output. Okay, if you make it further large, okay, if you make it 1.2 volt, then you will find that the amplitude of this pulse output is increasing, which is expected. Okay, which is also expected. So you can measure this value again. Okay, you will find that this value is equals to 43.342 millivolt. Okay, just note down this value, 43.34. Okay, so that value I have noted down over here. Okay, again your minimum value is equals to 0. Fine. Similarly, you can vary the values. Okay, DC voltage you can make it 1.3 volt. You can measure the output pulse amplitude. Okay, it will further increase. Okay, and output pulse amplitude will be 0. Okay, and then you can directly go to the 5 volt. Okay, so I'm just going directly to the 5 volt. Okay, here. So you just make it 5 volt, and then you can observe the output. Fine. So what you can see here is that amplitude of the pulse in the output has increased a lot. Okay, so you can just adjust this voltage sensitivity of the CRO. Okay, you can adjust it. Okay, you have to make it large a little bit. So now here you can see that we are getting a pulse output. Okay, and its amplitude is actually have increased. This also happened in the case of pulse amplitude modulation. Okay, if you have gone through the its theory, then you must be aware that in the pulse amplitude modulation, when the message amplitude is increasing, the height of the pulse will also increase. Okay, so it is increasing over here. Fine. So you can measure it again. Okay, and you can note down the value. So it is coming as 1.815. So here I have noted down this value 1.815. Okay, so now you can make it 6 volt. It will be coming as 2.3, and here the minimum value remains 0. Now the interesting thing is that if you make it 6.2 volt, okay, so just I will show you this result 6.1. So if you stop it, just you make this DC voltage equals to 6.1. Okay, 6.1. Then if you execute it, okay, this voltage have again the amplitude of the pulse output is increased. Okay, and this type of output is appearing. Fine. So that value we can measure, and you can tabulate the result. Now if you increase it further, okay, 6.2 volt, fine, 6.2 volt, then what happens is you can see that this waveform is actually starts shifting upward direction, shifting in upward direction. Just you see this bottom. Okay, just you see this bottom. Okay, this waveform is starts shifting in the upward direction. Okay, and that upward shift is not required. You remember when we are doing the sampling, this upward shift is not required. So that is actually this particular value 6.1 is imposing a limit that this maximum amplitude that we can give in the message signal, that should not exceed 6.1. Okay, for this particular circuit configuration. Okay, you can analyze the circuit. Okay, you can analyze this circuit. You can just because it is a potential divider circuit. Okay, whatever the voltage we have applied over here, you can solve this circuit for the case when your pulse is equals to 0 volt and your pulse is equals to minus 5 volt. Okay, and accordingly you can get the output. Fine, they satisfying all the KVL KCL equations. Fine, so that equation will be satisfied over here. Fine, so that you can cross check. So what I want to make that when it is 6.2 volt, okay, you can see here this minimum value is not 0, okay, but it is 43.305 millivolt. So this is what I have noted down, 43.34348. Okay, so this is the value. So basically what happens is when the input message signal or an ADC value, okay, if it is greater than 6.1 volt, then this pulse output will start shifting in the upward direction, okay, which is not required for doing the pulse amplitude modulation or performing the unipolar sampling. Fine. So you can stop it over here. Again, you can further increase it, just you make it 7 volt. Okay, you can definitely observe that there is a large shift. Okay, it has shifted in the upward direction. Okay, so that's why I have just taken these values to you. You must have the idea that while doing the sampling or pulse amplitude modulation, okay, this particular value we have to keep in mind. The thing is that the pulse output was started appearing when the input voltage was 1.1 volt. Okay, so it means that my minimum voltage, okay, of any message signal should be equals to 1.1 volt, and it should not exceed the value 6.1 volt. Okay, so it should be within this range. Okay, it should be within this range. Okay, and here you can see when its maximum value is 6.1 volt, then here you can see at 6.2 volt this value is maximum, it's coming out as 2.398. Okay, this is the maximum voltage of or amplitude of your pulse output. Okay, this output. Okay, here you can see when it is 6.2 volt. Okay, 6.2 volt. Here you can see this result 6.2 volt. The maximum pulse output will be equals to your 2.39 volt. So I am just telling you this value because I will be conducting one of the experiment which is called as pulse code modulation. Okay, that time this explanation will be required. Fine. So you be connected. I will be uploading that particular lecture very soon. Okay. So you can see this value is equals to 2.398. Fine. So now you can see that our range of input should be varying from 1.1 volt to 6.1 volt. It should not be 6.2 or 6.3. So maximum up to 6.3 you can go because this shift is very small, but still it will be good if you are having this value range from 1.1 volt to 6.1. Now, accordingly, we have to select our message signal. Fine, because we have to give the message signal. I will be using the sinusoidal wave as the message signal. So you just disconnect this one. Okay, I'm just disconnecting this DC source. Okay, and now I will be connecting one of the message signal. Fine. So I'm just connecting over here one of the message signal. Okay, and now I have to set the parameter for the message signal. Fine. So how to set this parameter? Just you see, what I will be doing is I am just using this value. I'm just taking the message signal is of sinusoidal type. Okay, you can take any message signal. You can also take the triangular wave, no problem. Okay, so if you take the sinusoidal, then I'm just taking the message signal frequency equals to 1 kilohertz, and here I am taking the amplitude equals to 2.5 volt. So this is V maximum value. So its peak to peak value will be equals to 5 volt. Fine. So when this is 2.5, V maximum is 2.5. If I won't give any offset value, okay, let us suppose if it is zero, if it is zero, then what happens is its minimum value will be equals to minus 2.5. That you remember. Okay, so its minimum value will be equals to minus 2.5 volt. Okay, and that time this type of output we are going to get, because most of the inputs are actually, it is below 1.1 volt level. Okay, it is below 1.1 volt level because I said that it should be above 1.1 volt. Okay, or 1 volt. It should be greater than 1 volt. It should be, minimum value should be equals to 1.1 volt, and then the maximum value should be below 6.2 volt. Okay, so right now in this case the minimum value is coming as minus 2.5 volt. Okay, and that's why the entire message signal is not going to be sampled. Okay, because most of the time your transistor will be in the cutoff mode, it will not be operating. Okay, it will be in the off mode. Fine. So what I have to do is to just make the minimum value. Okay, here you can just connect another CRO. Okay, just I am connecting another CRO so that you will be able to see the waveform for the input. Okay, so let me connect, this is your function generator 2. Okay, so just you connect this one to this. Okay, and then just I'm connecting the ground signal. Okay, ground point over here. Okay, so you can connect the ground here, and now you can observe the waveform. Okay, so once you will be running this one, you will be able to see this waveform. Okay, so this waveform is nothing but, here you can see this waveform. Okay, so this waveform is I'm just making it 2 volt. So here you can see it is of 1 kilowatt signal, and its minimum value is going to minus 2.5 volt. Okay, because it is of 2 volt, step size is 2 volt. Okay, this bottom point is minus 2.5 volt. So even you can measure it by just bringing this pointer. Okay, so here you can see that it is coming as minus 2.5. Fine. So now I have to bring this bottom to 1.1 volt. Okay, so how much DC we have to add? We have to add 3.6 volts, so that this point 3.6 DC, positive DC value we have to add, so that this will be shifted in the upward direction. Okay, so while after doing that one 3.6 volt, okay, taking 3.6 volt. Okay, here you can see this waveform is now gone up. Okay, it is shifted in the upward direction. Okay, and now you can measure the bottom. Okay, you can measure the bottom. So here you can see that this bottom point is now coming as 1.1 volt. Fine. So now we can observe the output. Fine, you can observe the output. So just you execute this one. Now you can observe the output. So now we are getting this sampled output, or you can say it is a pulse amplitude modulated signal, or your unipolar sampled signal. You remember that your value is your peak to peak value for this massive signal we have taken as 5 volt, and the bottom point is your 1.1 volt. So the maximum value will be equals to 6.1 volt. So we are actually satisfying this condition. Okay, we are satisfying this condition. The maximum value is not greater than 6.1 volt, and the minimum value is also not less than 1.1 volt. And therefore, we are going to get this beautiful unipolar sampled out. So I hope this lecture must be useful. So you try to implement the same circuit, okay, using the MultiSim. The same circuit I will be using for further experiment. So I hope this must be clear. If you have any doubt, any query, please drop your queries in the comment box. So thank you for watching. I will be coming up with the next lecture.